Okay, for today, the first thing I want to talk about is the labs folder. I'm going to back up one notch here just so you can show you a big picture where it is. It's the second folder in the course called labs. Once you go in there, one of the things that's been assigned recently, well, the Venn diagram has been out there for a long time. We've talked enough about that hopefully you're going to do a good job on that when we grade that, which, judging by how long today's lesson is not today, but probably tomorrow. This Mad Mouse lab is pretty technology intensive, and so I wanted to give you a few little hints to help out. So first thing is, if you haven't already, you're going to want to download Desmos, the Desmos app for your iPad, because to graph these things, you'll want Desmos. You could graph them on a regular calculator, but the problem is it's a lot harder to limit the domain. Here's what I mean. Let's say you're smart enough to figure out that this right here, that part, is a parabola. And you're going to make a little parabola part of your graph. Do you get, if you use a normal graphing calculator, your parabola will just keep going. It's not just going to stop. It's going to keep, like the whole parabola is going to keep going like this, and it'll go forever in both directions, and you don't want that. You want it to stop. So you can do that with Desmos by saying, let's say that you pick this to be 5. Having a hard time writing here without my markers. If I put a 5 here, let's say that you want this to be 15. Let's say that you want this to be 25. And let's say that you want this to be 30. Okay, you get to pick those. Okay, so you pick them to be whatever you want for the x-axis. The rules are this. It must start at a point A 30 meters high. B and C have to be 10 meters high, as in they both have to be right at 10 meters. And point D is 25 meters above ground level. So this right here needs to end with a nearly zero slope. Those are your rules. If you follow those rules, your roller coaster can look like anything as long as you do those things. So start at the right place. Start at 30 meters. Up here. Oop. Up here. And these two spots have to be at 10. It doesn't say how high your roller coaster has to be off the ground. That's your choice. You could do something really cool and make it go underground if you wanted to. There's no rule about that. So you got a lot of freedom. One thing it says is that this has to end around 25. To get here, if I go out here, it's ending around 25, and it needs to be fairly flat, not zero slope. There's no way to get a zero slope. But if it's a roller coaster, do you get that you don't want to be ending in a really steep spot? That's not how it works. The car usually comes up to a kind of a flat spot where you stop the car and you get out of it. Okay? All right, so you just basically need 3 little functions here. And I'm not giving all of them because I want to, keep the challenge in the problem. But I'm going to give you a start on the straight one, this one. Would you agree y equals negative x is a line that sort of tilts like this and is straight, and y equals negative x? If you don't know that, y equals negative x would look like that. Okay? But I would need it to be moved over a little bit. Or, in other words, moved up a little bit. So if I take this thing and I move it up here, now all of a sudden it's pretty close to right. It just isn't tilted quite steep enough. See what I'm saying? All right, so you want y equals negative x, but maybe a little more slope. So, suggestions? Anybody? Negative 3x, I like it. Now it's steep enough. How do I get it to move up like that? Plus 30. Okay. There. You get your first equation. Now, isn't that going to go forever, though, in both directions? It will, unless you limit its what? Domain. And that's about the what? X or y? Domain is about the x. So we've got to limit the x. So what you can do on Desmos that you can't do on your regular calculator is easily. There's actually a way to do it, but it's not worth trying to teach you because Desmos is just so much nicer display, and it's big. And how do I tell it I want x to be bigger than 0? I say x has to be greater than 0. And then the line will just keep going like this forever back here where you don't really need a line. Know what I mean? And then, what if you want to put in another constraint? Like, do you want it to keep going forever this way? No, you don't want it to keep going down forever. You want it to stop. So, you could make it stop at, well, again, you get to pick what these numbers were. Maybe you wanted this to be at 30 feet. I don't know. You got to decide how far over you think that is for your... You get to pick. Now, I know some of you would really just like it if I told you exactly what to do, and you would do it. But the labs are not supposed to be that way. The lab is supposed to be a challenge, and that means as long as you follow the minimum directions, you can do it any way you want to. So I've had kids make some really cool looking roller coaster things. It doesn't have to just mimic what the picture is on the board. Okay, but a roller coaster has to have at least one part where it goes down pretty fast, right? And then it has to go back up again. So we suggested that you have a parabola and a square root and a line. So we just thought this would be a start. Can it have more than that? It can. It can have more than that. But I just gave you the equation for the line. What I want you to talk with the kid next to you is what would be the equation for this parabola? Well, we all know it's y equals x squared. Come on. So I know parabolas. But what about this parabola? This parabola, if we agreed that this was going to be 15 right here, and this was going to be 25, you want to limit it to between there? And you want it to be moved over and up, because a normal parabola would be here, but you want it to be over and up. I want you to figure out with the kid next to you what would be a good starter equation, which you can always later plug into Desmos, see if it actually looks right. Know what I mean? All right, so rows 1 and 2, you don't have to slide next to each other, but you, for right now, are trying to make sure they're on the right track for the parabola part of this lab. I'm going to pause for a second while you guys work on that. Okay, it totally depends on you and what you want this to look like, but here's some thoughts. Would you agree that it needs to be shifted to the right and therefore x minus something? And if I made this 15 and 25, what's the logical thing that's right in the middle of that? It's exactly between 15 and 25. Come on, it's not that hard. 20. So x minus 20, quantity squared. And then it's also moved up a little bit, right? That was totally up to you. It says question mark. You can go up any amount you want. So let's say we go up 5. Okay. There's a parabola. What's wrong with it? It's going to go forever. How do you keep it from going forever? Underneath that in Desmos, say x is greater than what? Well, the way I did it, I made it 15 and 25, right? So I could say something like that. All right. So that is as much help as I want to give you, and the main reason I wanted to give you that help is because it's not really fair for me to say, hey, go out, figure out Desmos and that it can do domains. I had to give you a little help on that. Now, you have to just as long as you do what it says, which is in the purpose statement there, then you have a lot of latitude on how exactly it looks, etc. And remember to follow the procedure thing, which is we've got this format for all labs. And I even wrote on the board here, you can't see it for people at home, but I'm going to say it in words. The procedure is where you say in words what you needed to do. So like what you just did there, figuring out the equation for the parabola, you'd say it in words. Well, I needed to figure out parabola, so I knew I needed to shift it to the right 5, and I wanted to go up 3, and so I wrote the equation like this. You say in words in the procedure section what you did. In the calculations section, that's where you actually show the work, which would mean, well, it says right in the format for all labs, this is where you would show what the equation was. The other one, you could just say, here's what I did, and then in the show your work part, the calculations, that's where you actually put, here's the equations that I got then. It's like, so one is like saying what you're going to do. The other one's like, here's what I did. Here's the answer. Here's the work I show. And again, we aren't solving equations here. You're kind of setting them up. So it's hard to show much calculations. Later on, we're going to have a lot more of the showing your work part, where you have a bouncing ball and you're like having to show how you solve this equation to figure out exactly how long the ball's been bouncing. And you got a lot of work to show, like solving equation work. Not that much of that on this lab. How do you end the lab? Conclusion. What is your conclusion in this case? It's a thing. You made a roller coaster out of functions that have been shifted, and their domains have been tweaked. All right, enough help on that. Now I need to teach you the new stuff. So, if you haven't already, find this file. It's 3.1, day 1. First couple slides are about the Mad Mouse, which we already just talked about. And now, first thing, combining functions. If you are adding a couple functions together, it is as simple as you think. X squared is one function, and x plus 2 is another function. And what if I add those functions? Well, then I take x squared plus x plus 2. It is that simple. If you add the subtract or multiply or divide, it's just what it says. What do you think FG is saying? Even though there isn't actually a symbol in there, what do you think that's saying to do? Multiply them. So you just take the f function and times it by the g function. Here's a mistake I just did. You get the mistake I just did? The g function needs parentheses around it. Otherwise, your x squared would not get distributed. So don't forget, when you multiply or divide, there needs to be parentheses around it. Okay. I tell some of you are not with me, and it's a little annoying. Please be with me. All right, next, this line. On this page, we are doing what's called the difference quotient. This is a thing from calculus. And do you remember last chapter how I made you stick in x plus h into functions? Do you remember doing that? We did that for a day. And then we even did one where we then subtracted f of x, which isn't that hard. Here's f of x. You just subtract, in parentheses, 3x minus 5. So this whole difference quotient thing is difference means minus. That's the difference part. The quotient means divide. You also divide by h. So there's the formula for the difference quotient. We're not going to make you memorize the big nasty thing, but that formula is used in calculus to see what the slope of a line is. This line is curved. Do you get the slope kind of depends on what points you pick? If you pick this point and this point, the slope would be that red line. But do you get, if I picked this point and that point, I could have a slope that's almost 0, because in that little zone, that's what the average slope is. So anyway, this is called finding the average slope. It's called the difference quotient, and you're going to use it in calculus. All I need you to be able to do is put that into this function, then subtract the original function, and then divide it by h. We did lay a little groundwork for this before, so you should be able to do this now. Start by putting x plus h into this function. Well, the way I like to do it is 3 empty spot minus 5, and then you drop it in, and then you multiply it all out, and then don't forget, now you got to subtract the original, and then you got to divide by h. So there's a start for you. Give that one a try. I'm going to pause for a second while you multiply and cancel, and a lot of things there's a plus this and a minus that, and they cancel, and at the end a lot of it simplifies down, and the answer might just be 7. All right, I'm going to pause for a second while you give this one a try. Okay, this one, x plus h. Multiply it out, 3x plus 3h minus 5. Then what? Subtract f of x. Minus, and do you remember to put the parentheses in? If you didn't, you screwed up a negative, which made it all not work. I warned you, got to put a parenthesis around that so that you will distribute the negative when you're subtracting the function. That's the common mistake, is people forget that part right there. Then that's all divided by, it's called the difference quotient. Quotient means divide. Divided by h. Did you notice that the 3x and the negative 3x canceled each other out? Raise your hand if you noticed that. Awesome. Then the 3h is still there. There's no way to cancel it. But the negative 5, and remember this, I'm going to back it up a bit so you can see it. Remember that this negative got distributed over here. That makes that positive 5, cancels the negative 5, and they're both gone too. Could you get the door for us, please? Thank you very much. And that leaves us with only 3h over h, and the h's cancel, and you just get 3. Okay. Do you remember me saying in the first place what this thing does? It's a complicated equation to find the slope. And isn't that 3 the slope of the original equation? Yes, it is. If you had really understood what I was saying a second ago, that it just finds the slope, you'd have been able to just go, I know where the slope is. It's right there. It's a 3. So you are now smart enough to learn a much more complicated equation to find the slope. Why would you want a more complicated equation? Because it can handle curves. You remember our old slope equation? Rise over run? It can't handle curves, but this can. This complicated thing right here can find you the slope of something that's curved by determining a distance between these two, and then saying, okay, if I pick these 2 points, the slope would be this, and then finding the average slope in between those 2 points. Okay, you don't have to know all the details, but can you grind out the algebra and get 3? How many of you actually got 3? Okay, then you obviously can grind out that algebra. Now, it gets more complicated, of course. So when we get to this one, if you're smart enough, you can say the answer before you even try it. What's the answer? Negative 5. It's just the slope, so it's done. How about this one, though? I don't know what the slope of that one is. It kind of depends. Then you need the big formula for it. This is going to happen another time later this year. Do you remember a squared plus b squared equals c squared? You remember that one? That is the formula that works for right triangles, right? But you weren't smart enough until now to let you know that the actual formula that works for any triangle is a squared plus b squared minus 2ab cosine of c equals c squared. Why would you ever want to use this if you could use this? Because this one only works on what kind of triangle? And this one works on any triangle. And if you have a choice, if it's a right triangle, it's the smarter thing is to actually use the easier formula. But the reason that works actually is because this part cancels out because the cosine of 90 degrees is 0, and that makes that whole part go and it's gone, and that's why when it's a 90-degree angle, it still works out to a squared plus b squared equals c squared. But again, you weren't smart enough to, like the first time you learned this was when you were in probably like 6th grade or 7th grade. They're not going to try to teach you this one, even though this much more powerful formula because it works on every triangle. All right, same idea. We taught you slope before. Now we're teaching you slope again, except you can handle what's the slope of that. And you do have to get a little more specific. The right answer is in what zone? And you'd say, oh, from here to here, I want you to find the slope in there. Then you can use that formula we just did to find the slope in there. All right, so your job on a typical test for us would be not this one, because I know you would be smart enough to remember what I said, and you'd go, oh, the slope's negative 5, done. So we're going to give you one that has squared in it. Okay, so let's do this one now. 2 empty spot squared plus 4 empty spot, and that's what you need to figure out. You stick in x plus h, then you subtract the original function, and then you divide it all by h. I'll give you a hint to see if your answer is on track. Your answer on this one will come out to something like All right, I'm going to pause while you give that a try. Okay, so what I hoped you would do here is stick in x plus h in here and here. And this part's complicated. I hope you didn't just go x squared plus h squared. People do that all the time. That's not what that is. Remember, this is like this. How many of you remembered to do it that way? Raise your hand if you did. Okay, awesome. If you didn't, you need to fix it now because we need to get you to do at least one of these correctly so that when you get to the test, you've at least accomplished this before. Because difference quotient is obviously a topic we're spending some time on. Obviously, it's something I could test you on. Now, one thing I did tell you, you would not have to memorize this formula. I don't want you wasting time trying to memorize a formula that we would not expect you to actually know off the top of your head. We will give you the formula if we give you a question like this. Okay. By the way, am I done? No. I got to now subtract what? What's the next step in this thing? I stuck in x plus h. Now what? Right there. I got to subtract f of x. So now I go minus, and I'm used to drawing with my finger now. I got to get back to the marker. Minus f of x, which is this. Don't forget to not just stick one minus on there. You have to put it in parentheses so that you can distribute the negative. 2x squared plus 4x. And the negative gets distributed. And then all of that's divided by, it's called the difference quotient, right? Divided by what? H. And I'll simplify this one down in a second, but I want you to try. Like, again, I said before, the answer is like, 6h minus 4 or something. Would you please check with the kid next to you and see if you get the same answer as them? Okay, let's see how you did on not forgetting to put the little thingy in the wrong spot or whatever. This should have been x squared plus 2xh plus h squared, and then you double them all. This 2 means double everything. 2 there, 2 times 2 is 4, and then a 2 there. Did I go too fast there? Or did you get that? Okay. Then I'm going to now add 4x plus 4h, and then subtract 2x squared, and then subtract 4x. Whew, messy. Now, 2x squared cancels negative 2x squared. Cool. Do you see anything else like that? 4x, negative 4x. Anything else? Nope. And it's all divided by h. Good. And now, is there an h in all of these that I could factor out? Yes, and if you can factor it, you should. H comes out 4x plus 2h plus 4 all over h. And why was that good to factor that? Because now I can cancel it. And there's your answer. 4x plus 2h plus 4. If you didn't get that, but you see what you missed. In other words, if you know what you didn't know, then you're fine. Otherwise, maybe you'll have to go back and watch this video again and see what just happened there. All right, you need to know how to do that. That's called difference quotient. Next, I'm just going to briefly gloss over this and say, do you get that companies would have functions? Like, for instance, for their costs. If you're Apple, do you think they care what it costs to make their phones? Yeah, it's kind of a big deal. Like, if the costs get out of control, all of a sudden they want to sell a $1,000 phone, but it costs them $900 to make it, they're not going to make much on their phone, are they? You know what I mean? Like, if you can sell cans of pop in the parking lot, but it costs you $1 to buy them, and you can only sell them for $1.25, you're not making much. You know what I mean? But if you could go to Costco and get your pop for like $0.25 a can, and you can sell it for $1.50, all of a sudden, oh, I'm making some money. All right, so companies have cost functions, and this one's called a price function. You might think it would be a profit function, but little p in this case is the price function. I want to just challenge you with some simple economics. If Apple decided to launch their newest phone and charge $5,000 for it, do you get they wouldn't get that many people to buy it? Some people still would. They're like, I got a lot of money. I don't care. It's the nicest phone. I'll buy it. But other people, well, there's a lot of people would say, no way, I'm paying $5,000 for a phone. Let me give you a heads up. Apple will be charging $5,000 for a phone. It's just not yet. Because when they first started, most people only paid $200 for the iPhone, and now they got us up to $1,000 for their iPhone. You can't tell me it's going to stop there. No, that's true. It's true. They can't make people buy them, and I know a lot of people are saying $1,000. I'm not paying $1,000 for the phone. I'll choose one of those cheaper options that's like $700 or whatever. And there's even cheaper options, way cheaper. If you're willing to go to like Android world, you can get a phone that's a smartphone for $100. Not saying it's as good as an iPhone. It's not, because it's $100, but it's only $100. You can even get cheaper than $100. There's smartphones that are cheaper than $100. Anyway, my point is, we think say the number $5,000 smartphone, and you're like, yeah, nobody'd pay that. They're gonna. It's just a matter of time. Might be quite a few years from now. All right. So, price function. You can't just charge whatever you want as a company. I mean, you can, but then all of a sudden nobody buys your phone. So, do you think there might have been debate at Apple about where to price their phone? Some executive might say, let's price it at $800 instead of $1,000. We'll still make money. And what would be the argument that you would want to do that? Why would you say, let's do $800, not $1,000? Yes?
Because more people would appeal to less than $1,000 than they would to $1,000.
Okay, so you'll sell more phones.
Well, yeah, but the idea of being over like spending $1,000 on a phone versus spending like $800 on it, you think it's so much less.
Yep. Even 99 cents, like, that's the reason they charge things at $7.99 instead of $8. Because you see the 7 first, and your brain's like, yeah, that's cheaper, a lot cheaper, even though it's a penny. So you're right. But the main argument, if you were going to price it cheaper, is let's get market share, it's called. As in, let's get everybody buying an iPhone by making them cheaper, way cheaper. Because the flagship Android phones, they're like $1,000 too. The very best, not Apple phones, are like $1,000 also. So they might go, well, how about we try to really undermine the other company? Do you get how that would kind of work? Think about it this way. If they were to sell their flagship best Apple phone is like $200 cheaper than the best Samsung phone, do you get how they could hurt Samsung pretty bad by doing that? So somebody out there was probably arguing for that. Do you get there's some other executive was saying, I think we should price it at $1,200. Try to like make as much money as we possibly can, because right now Apple's really hot. Let's make money while we can. They'll pay it, whether it's $1,000 or $1,200. The Apple fans are going to pay it. So anyway, there was probably a debate because there's a price function, and it has to do with, it's called supply and demand. And your price, if you set your price really low, a lot more people will demand your phone, and a lot more people will buy it. But you don't make as much on each phone. All right, then the last thing I want to talk about is, these are just functions. So if I stick in C of 0, it's not super complicated. It's saying stick 0 in the cost function. That would mean a 0 right here. What is 60 times 0? 0 plus 200. Why is there some $200 in costs, even if you don't make any phones that day? Why would Apple say there's going to be costs to making their phones, even if they don't make any phones? Do you get to have the factory either way? The factory is sitting there. They have to heat it. They have to pay some guy to walk around and like clean the floors, and they got to have the parking lot ready, and they got to, you know what I mean? They got expenses that happen whether or not they're making any. Those are called fixed expenses. All right, so last one is profit. Profit, big P versus little p. The profit is the revenue, like how much money you brought in, minus the costs. If you went out for the day of selling water bottles at the state fair, how many of you guys went to the state fair this year? Awesome. I went to the state fair. It was fun. And did you notice on the way into the fair, there's a lot of people like selling water bottles before you walk in? Because once you get in there, it's like $3 to buy water. And outside, they sell them for like $1. But do you get they probably only paid like 10 cents per bottle themselves? So they're making money. That's okay. It's as long as, like they don't get arrested for selling without a permit or something. They'll make some money and, they might sell 50 water bottles and make about $1 each and they made $50. They're making what? Profit. And it's their revenue they brought in, let's say they brought in $50 minus the cost of the actual water bottles. Let's say they only paid, $12 for their water. It'd be 50 minus the 12. They made money. All right.
Interruption?
Yes. Here's our last thing. You've learned to multiply, divide, add functions, and it's pretty simple. This is multiply the two functions. Would you please take these two functions and multiply them and see if you've actually learned anything here? The only thing I haven't taught you yet is how to find the domain of these new functions that are made up of two parent functions. Are you timesing x squared times 3x minus 1 with a parenthesis around it? Because otherwise you'll just be randomly timesing it by the first term. You got to times it by both. So did you figure out that this is 3x to the third minus x squared? Raise your hand if you caught that. Okay, awesome. Now the only thing I have left to teach you is how do I find the domain of this new function? Have you ever heard of a doctor asking for your health history? Maybe you guys are too young to have this happen. But when you go into the doctor and they're like doing a physical on you, one of the first things they ask you is about your parents. Why? I'll give you an example. I have a friend of mine who's about 50. His dad died when he was about 50. Like the dad was 50 when he died. And his dad's dad, as in his grandpa, he died at like 45. Do you get how that's a pattern? And that might mean he's going to die at 50? Yeah, that happens. That's a real thing. It could mean it could be a heart attack. It could be, well, then the doctor wants to know, well, what was wrong with your grandpa and your dad that made them die at 50? Because that's pretty young to die. So they might want to catch that so that if you might have a tendency to have a heart attack or whatever, they can watch you really close on that. Keep an eye on your heart, make sure it's everything's okay there. My point is, these functions are like the parents. And whatever weaknesses they have, they might pass down to the children. Now, this was a bad example. It's a super easy one because it's like you're just learning how to do this so we don't make the functions complicated. But do you get the domain on this thing was all reals? Everything works in that because you can't crash it because there's no square roots and there's no denominators. And how about this one? What's the domain on that one? X squared. What would kill that function? Nothing would kill that function. So what's this domain? All reals. So if this one's all reals and that one's all reals, then all the children have no issues. There's no domain issues. It's all reals. It's kind of like parents that are like perfectly healthy and live to 100 and both your parents are like that, then that gives you good genes. That it's a real thing. It's sad, but it's true. Like you can be blessed with like super healthy genes, or you can be, like not blessed by, in my family, for instance, my father had a form of cancer, so that means I have an increased probability of getting that kind of cancer. My mom was actually super healthy, so yay, I don't have to worry about anything for my mom. Oh, wait, she did have a strange heart arrhythmia, which meant her heart had a strange heartbeat, but it worked, and it worked all the way till she's 80. So it's not a super long life, but she, that doesn't give me anything to worry about. All right, so this function and this function were perfect. They didn't have any weaknesses. So I'm going to give you two that do. F of x equals 1 over x plus 2. That has a weakness. Kind of like some people are allergic to peanuts. What's this function allergic to? -2. So remember, we don't say the domain as that. We say the domain as everything works except. I set my marker down somewhere and I can't find it. Bad hour for markers, let me tell you. I'm going to put this one back in its place for now. Okay, so I'd say the domain on this thing on a number line would be this. Why did I put it on a number line? You'll see. Here's g of x. It's got a weakness for what? Well, would any negative number crash this? No. How do you do these again? I hope you haven't just dropped that from your brain. We had a test on it. You remember how to find this? You go x plus 5 has to, well, be positive. Well, how do you say that math-wise? Greater than or equal to 0. And then that means x greater than or equal to negative 5. Does that ring a bell? Okay, so that's its domain. I'm going to put it on a number line, and I think you'll see why. Here's negative 5, and it has to be greater than or equal to that. So I fill it in here, and it goes forever that way. These two functions, f and g, these guys, they have domains. They have a child, little FG. He's a spitting image of mom and dad. Little FG, which, by the way, is what? Well, it's this 1 over x plus 2 times 1 over x plus 2 times the square root of x plus 5. That's FG. And what is FG's domain? You look at the two parent domains, and you see where they overlap. Ever heard of intersect before? The little upside-down U thing? It's the domain of F intersected with the domain of G. That's the math way to say it. I like to say it this way. See where they overlap? From negative 2 to infinity, they work. That means all the things in there that are bigger than negative 2 won't crash this function. And I know some of you are like, but there's other numbers. Yeah, we'll get to them. You get if I stick in a negative 2, I would have a problem. That's why I have a parenthesis on that negative 2. Not the bottom one. The bottom one doesn't have a problem. The top one does. So that means I can't have negative 2 in my domain. But isn't there another little zone where these guys would work? Yeah, in there. And does that little zone include negative 5? Is like negative 5 going to work? Yes, it does. So you'd say from negative 5 with a bracket up until negative 2, and not including negative 2, it works. And then what do you put between them? Do I want where those overlap? No. Union. There's your domain of a composite function. Actually, that's not technically a composite. There's your domain of a composed function. Anyway. So, moral of the story, if you have homework, which you do, that asks you for the domain, let's say they ask you for the domain on this. This is a super easy one. Because the domain on this is all reals. Domain on that is all reals. Because there was no square roots that could crash and no denominators that could crash. Then the children are bulletproof. The children have great genes. The children all have all reals as their domain. But we're not likely to test you on that because it's just too easy. The word would just spread amongst everybody. Hey, the ones that they have in the test, it's just all reals. And then everybody get it right. All right, so what are we going to more likely test you on? Ones where there's domains. So let me show you what I'm talking about. Here is a typical question from tonight's homework. It starts right there. Do you get this one has all reals and this one has a domain that is not perfect, as in not everything works? Okay. So this one's all reals, and this one, again, you can figure out what the domain is. X has to be greater than or equal to something. You figure it out, okay? Now, I don't think you need to do this much practice, so we're going to skip this one completely. And this one, since the domain, when it's all reals here, and it's x cannot equal 1 here, as in everything except 1, then this is actually super easy. Because what do you think all the children are going to pattern after? All reals or this one? It's the other one. And if you intersect all reals with anything else, the answer is the other thing. So this would be a little too easy to do the domains. So you may, on this one, not do the domains. All I want you to do is add the functions, subtract the functions, multiply the functions, and divide the functions. Don't have to do the domains. Okay, so that page, skip the bottom and only multiply, add, subtract. But here's the catch. That and that, when you add them, need a common denominator. So I'm going to put this over 1 to remind you, you can't add them the way they are. Don't move yet. Stop. I got to tell you the rest of the homework. This, all I need you to do is one problem, because if I was going to use this thing, some of you are smart enough to remember that this is about finding the slope. What's the slope on this one? 2, so I don't have to do that one. It's too easy. This one's slope is 0 because it's a straight line. That one is the only one you do on this whole page. You can just memorize this? I hope so. And then this one we're going to skip. As cool as it is in the real world, it adds a ton of time to your homework, and I'm going to say you can skip it. And on this one, all I need you to do is these 2. Just the top 2. These will make you think. They're not super hard, but it makes you think. That's all I got for you for today. Have a good day.